want to introduce to you Steve Wardell. Steve is the Director of Imaging at ATS Automation, the Chairman of the Board of the AIA. He's also a member of the A3 Board, which is the Association for Advancing Automation. Just a quick understanding of the AIA and the A3, they are the largest associations in the world focusing on imaging, and then the A3 on automation. And they're a great industrial group for furthering things like standards, education, and bringing together people to make automation and imaging happen. So they're wonderful groups. If you're interested in that, please just drop a note into the chat area, and we're happy to give you some information on how to make that go. Steve's got 30 years experience in automation, providing direction to meet machine vision solution needs, and he holds a bachelor's degree in mathematics, applied math, and computer science from Waterloo. Just a quick note, we do have people online that are going to be answering questions for you in the background, and we're going to make sure all of those get to Steve as well afterwards. Steve, at this point, I want to hand the controls over to you, and thank you so much for being here today to do our keynote.
Well, thank you very much, Greg. I appreciate it. I'm hoping that, the quick chat that we have now will be informative to some of your guests here today. As you mentioned, I'm going to be looking at things from our perspective as a machine builder and an integrator, and kind of take us through the steps. So I'll kind of start off with a quick introduction about who we are. ATS is a large-scale machine manufacturer, one of the largest in the world. And as you can see from this, we're in over 20 different countries with 50-plus offices, more than 4,000 employees. And our real purpose is to design and build automated solutions. We're a custom automation provider to many different markets using different capabilities. Automation, integration through products and services are being deployed to many of our customers in the life sciences market and the transportation side of things. Do a lot of work with nuclear and solar and the energy side of things, as well as consumer goods and food and chemical products. Essentially, when you go into a factory and you see equipment like this, there's a chance, potentially a good chance, that you're going to be looking at some ATS equipment. We design and build this type of machinery for our customers so that they can take that automation and produce the product that they're giving out to their customers. Specifically on the imaging side of things, because this is an imaging summit, and I'm the head of our imaging group here at ATS, I want to talk a little bit about who we are within ATS as an imaging group. The timeline that you see in the bottom left-hand corner there, which is very fine, you really can't get much of the details, essentially just says that since our inception back in 1978, we've been involved in various different aspects of machine vision almost since when ATS was originally started. Our founder, Klaus Werner, was a big proponent of the use of automation and computer controls, and that quickly led to the use of vision systems in the solutions that we put forth. Greg mentioned that I sit on the board of the AIA and the A3. ATS is also one of the few certified system integrators as accredited by the AIA, which means that everyone within our group is certified vision professional, either at the basic or the advanced level. Some of the things that we do, what we do is design, build, deploy machine vision solutions for the systems that we build. And we do that using standard approaches and products that we've developed over the years. This is one of our controllers that we've designed and built as a standard unit for the heart of most of the vision systems that we put together. Here are some of the examples that we use and that we've deployed over the years, various different types of applications. As you likely know, in the machine vision world, there's cameras and sensors can be used for a lot of different things, whether it's guiding a robot, whether it's doing defect inspection, whether it's looking at labels or reading barcodes. You name it, it's gone from a point, 15 years ago where it was on 20% of our machines to now where it's on 95% of our machines. But the real focus of what I want to focus in on today is how we do it. And what I'm showing here is essentially the process that we take each and every time we put together a machine vision solution for our customer. Since we're a custom manufacturer of solutions, every application that comes to us is a little different than the last one that we did or than we've done in the past. So we have to go through a process for every customer, and it starts out at the beginning with an RFQ, or request for a quote from the customer. That hopefully leads to a quote that we put together for them to meet their needs, eventually leading to a PO for us to get started on the project. Once started, we're into the design phase, the procurement phase, and then building, bringing the system together through integration, tuning it to meet all of the needs that it's supposed to meet as originally required, and then accepting it at our factory with the customer in presence. Through successful acceptance, we then tear down our system, ship it out to the customer, and do a site acceptance before we go into a long-term service role with that customer. As you can see, there's lots of different interactions between customer and ATS throughout this process, but the process kind of remains the same. And I'm going to focus in on 5 areas of it. One is initially understanding the solution. Secondly, designing the solution. Next is building it, followed by proving it, and then lastly by delivering it. So by looking at these 5 stages of a process, I'm hoping to share some of what we've learned over the years and some examples of how we've done things. And maybe you'll be able to take away a few nuggets of information out of today's presentation. So first off, starting step 1 with understanding the solution. I like to think the first thing that we do is not necessarily to understand the solution, but we have to understand the ask first. So we have to go from initially talking with the customer to saying, what are you really looking for? We have to ask the right questions to get to the bottom of what their problem is that they're trying to solve before we do anything from a concepting standpoint on a solution. If we're working within certain industries, make use of the regulations and the requirements that are used in that industry. For instance, we do work in nuclear and we do work in life sciences, and the regulations between those 2 different industries are vastly different. But understanding them at the beginning really helps to put together a proper concept. Another key area to look at is if it's inspection that they're looking for and they're already doing it, potentially manually, how are they doing it? If they've got standard operating procedures that they can make use of and share with us, that gives us a whole lot of information to work with right out of the gate. I also, at this point, try to make sure that we don't chase the shiny new toy. A lot of times, a customer will come to us and they'll say, we want the solution that uses this. Whether it's a fancy new camera or whether it's a fancy new algorithm or something that they saw, on a commercial somewhere for an inspection type of system. That's great to bring that information to us, but we don't start with the solution. We start with the problem and then potentially work into that solution. One of these days, a shiny new toy is AI. Artificial intelligence is out there. It's great, but it's not necessarily the right solution for every problem. So when we have customers coming to us saying, use AI, we'll step back, examine, and maybe go that way if that's the right solution. And then lastly, when we're looking at what the ask is, we have to also think forward to the end of the project of how we're going to test it and show them that we've met those requirements. So right early on, we're looking about the whole process and saying, if this is what we're going to be giving you, this is how we're going to test it at the end. For instance, a lot of times we get these types of applications where we're looking at labels or printed matter. Here's some examples. All of those, if you look at them, can likely be readable by human, but are all of those acceptable to the customer? Taking a look at the examples as early as you can and working closely with the customer to determine right and wrong is critical in getting started off on the right foot. Secondly, when we're putting together a system before eventually getting started, we have to look at the concept as a whole. When we do our concepting as a system, so we take into account not just the machine vision portion of it, but we look at how it's going to be mounted, how it's going to be wired up, how's it going to interact with the environment in which it's going. And when we look at the machine vision solution itself, we're not looking just at, you know, the shiny new toy or the thing that we know the best. Maybe we're a software kind of focus, but we have to look at the sensors. We have to look at the optics. We have to look at the lighting. We have to look at the system interactions and how the system works as a whole. I firmly believe that if you don't look at it as a whole now, you're not going to get it to the whole at the end. And then lastly, we say to ourselves, if this is the solution that we're concepting and we're putting forward, is the user, our customer, going to be able to use it as they desire? So we have to look at the user experience as well. I mentioned some of the customer interfaces, parts. If we're doing inspection on different types of parts, getting parts from the customer is critical at this stage. We had an application where we were looking at suture needles and doing defect inspection on them. You can see how many different types they wanted us to look at. We wouldn't move forward until we got all the examples of the types of defects that they presented, and a lot of that came from their standard operating procedures. Great bits of information that you can use when you're concepting as a system. And then lastly, move forward only in confidence. When you're quoting something, when you're putting together a system initially, before you've received the work, don't start unless you've got the confidence. And I mentioned working with real parts. Get the parts from the customers, work with them as much as you can in your lab or before the fact so that you understand. And then realistically assess your confidence based on what you know from experience, what you know from your education, and what you know from the testing that you've done through the concepting. If you go through that process and you say, you know what, I got a 50-50 chance of doing this, just say no to the work. You're going to get yourself into too much trouble further on down the road that it doesn't make sense to do it. Unless you've got a 90% or more confidence factor going into that work, then you can put that concept or that quote in front of the customer. So I understand in the industry, you know, the type of innovation summit that we're going through right now, that's a perfect way to keep in touch and learn and grow your experience so that you can offer that information up to your customer solutions. So we've done the concepting, we understand the ask, we've put together how we think we're going to go. Now, customer says, great, let's go ahead and do it. PO lands, it's time to get to work. And the first step of that is to design the solution. So some of the tips and tricks when going through the design is to utilize best practices. Pretty simple concept, and we all try and do it. We take it to heart when we're doing it. First off, one of our best practices is don't take the easy road unless you know that the easy road is the right road to take. So a lot of times, depending on some of the pressures on you, you could keep out on things or take a quick route. Don't necessarily do that easy road unless you know it's the right road to take. Keeping up with the current trends allows you to say those trends are the best practices these days. And then finally, when you're looking at the design, there's usually some sort of trade-off that has to come into play between quality, cost, or schedule. It's very difficult at times to be able to take all of them into account, meet all of them to their full extent. And so you have to know going in, if there's got to be any kind of give, where's that give going to be? Our desire is to never give on the quality side of things. We want a system that gets in front of our customer, it's robust and runs and runs and runs. So sometimes on the cost schedule type of things, you work with your project team to prioritize and make those right decisions. When looking at the easy road versus a proven solution, a good example is barcode reading. 10 years ago, 5 years ago, a barcode read type of application could be a machine vision solution. We would have thrown our standard product at it, our PC-based solution with, you know, off-the-shelf cameras and lighting, and built up a solution for it. But that, you know, that's been replaced by systems that are built purpose for that. They do the job, they do it robustly, and they do it with, you know, very economic benefits to them. That's an easy road that is proven and that you can take. Next, we look at when we're designing the solution, we design it as a system. Much like when we were trying to understand the ask originally and concept it as a system, now we have to also design it as a system. That means using the right tools for the job, knowing how those tools work together and how the different technologies work together, and then including everything that goes into the system. Oftentimes, you won't necessarily think about, okay, it's a machine vision solution. I've got to look at this image. I've got to make some decisions. But what do I do with that information afterwards? It's usually an afterthought. It doesn't need to be an afterthought. It's got to be built in right from the get-go. What about different types of functional modes? How do you do your calibration of the system if calibration is periodically required? Do you have separate routines that you build into that system, or does it end up being something you scramble at and you do manually when you need to? Think about these different types of modes of operation. Maybe you want to have a bypass mode so that if that vision system is not producing the information because something's changed to it, you've got an easy way to bypass it and go on to the next system. All of these things need to be taken into factor. I look back at some of the applications that we've done, and you know, when I look at the different types of technologies, lighting is key and critical to most of our setups. But not only lighting, also knowing the characteristics of the product that we're looking at. In this application, we were looking at a pod, a little container of a fluid. And this was the initial setup for a backlight type of setup. But what we had to find out were various different bubbles. Were there bubbles in the fluid, and how did it affect the overall volume of the fluid in that pod? Therefore, we need to be able to closely find those bubbles. And just the straightforward backlight solution did not work to the selection for the smaller bubbles. We ended up going to a structured lighting approach where we could dynamically change the pattern of stripes behind the product, and based on the width of those stripes and their periodicity, we were able to differentiate smaller bubbles from bigger bubbles and do that robustly. That's an example of knowing how the different tools can work with the product to give the solution that's necessary. In any design, image quality is king. Always start with the image quality. If you've got data in that image that's enough to make a decision every time, then you've got a good image. That's usually trying to bring out the proper contrast of the areas that you're finding in that image. And proper optic design, proper system design will give you that information. If you don't have that information in your images, then you're setting yourself up for a non-robust type of system. Also, when you're looking at the images, don't just look at the standard types of images that you're going to get out of your system. Look at the fringe cases. Look at the failure cases. What happens if a light turns off? What happens if a camera moves? What happens if the product has a bunch of hair on it? Those types of applications or uses of the vision system are going to happen in your system. If your system can deal with it, fault properly, handle it properly, not hang up, then you've got a more robust system. We're always looking for robustness. And then lastly, don't try and drive your vision system based on the software end of things. Try and make the software as simple as possible. That also drives to robustness, and it drives back to the fact that if you get the image right, the software should be easy. If you can't do it with an easy software algorithm, maybe those are the types of applications where you start getting into algorithms that are maybe AI driven. And I'm not going to go into AI today because it's a whole different topic and I could talk for hours on that. But those are some of the areas where we look at from a design standpoint. So here's a quick one. When looking at an application, we had a problem or a situation where we wanted to measure the tube insertion into a component. Here's one where the tube is coming out at an angle. Here's one where the tube's coming out at the right, within the proper angle. But how do you measure that radius of that tube? Because it's not a straight line. How do you say that, okay, well, that's good or that one isn't? Make sure that you work with the customer up front to say, okay, the radius is going to be measured from here to here, and it's got to be within these tolerances. Otherwise, at the end, you're still going to be having those difficult discussions with them. And lastly, on the design side of things, verify, rinse, and repeat. Do as much testing before you build the system of your design so that you can, again, have confidence going into the build, so that the further down the pipe in the process that you find mistakes, the more costly it is. Find those mistakes up front, deal with them when you can. Use your lab, do some prototyping, test early, test often. This example where we were looking at the overall length of a cartridge here, this is an image of what we ended up going with. It was using telecentric lighting and lensing. And it was only because normally we would have just looked at the top of it and measured it relative to a datum, but we knew that the heat fluctuations in this system were such that that datum could move due to heat expansion more than the tolerances of the overall length. So we had to look at the overall part. Understand your environment, get the solution correct. Okay, now we've designed it, we haven't built it yet. What are some of the things we take into account when we're looking at and we're building a system? Robustness. I've likely said it 4 or 5 times right now, but it's a key tenet for us here at ATS. We build for robustness. We use ruggedized hardware. We make designs such that they stand for and are not too complicated. You know, if we need a lot of adjustability, why do we need the adjustability? If we're only going to adjust it once a year and it takes half an hour instead of 15 minutes, that's okay. If you're adjusting it every day and you need that adjustability every day, then build it in. But weigh those factors so that you can have the system designed and built for your robustness needs. Robustness, simple things like connectors, IP67 and industrial connectors for Ethernet. You know, we very rarely use the RJ45 connectors anymore because we found they weren't as ruggedized for an industrial environment that we use. So we've gone to these style connectors, much more ruggedized, leads to a lot less downtime with our customers. During the build, this is a quick one, this is an easy one, use the right people for the job. You know, we in the imaging group are more software, vision engineers rather than hardware, tool makers, and electricians. So when we're putting something together and we're going through the integration on the floor, unless we can use just this set of tools, get somebody else to help you out. This is all I give my guys, and if they can't do that, do what they need to with this, then they know that help is needed. And then work with your teams to have the proper build support infrastructure. That's your IT group, so that you can have access to the systems as necessary. Your project team, communication. We use whiteboards and different meeting technologies on a daily basis with our team so that the communication can remain constant and clear. And that's really key when everything is coming together on the floor. The integration time is when you work most with most other people, and with you've got your infrastructure in place, it goes a lot smoother. Things simple like integration tags. When we put together a machine vision solution, it's at various different stages of testing. We just strap on one of these tags, fill it out to the level of testing it is, and then if we're not there, if somebody comes by, they can look at it quickly and say, oh, this system isn't fully calibrated yet, I'll leave it for them to do later. We've now built the system, we need to prove it. We need to go through the process of saying, is it right? And to do that, you have to have a lot of planning in place to do the testing. The test should match up everything that you have in the original specifications for the system. If it said it had to be orange, there's got to be a test that says it's got to be orange. If it says it has to be able to find a system to this level of tolerance, you have to have a test to show that it has that capability. Things like gauge R&R requirements, if they're called out in a specification, you have to go through a full gauge testing and prove it and show it to them that that is what it's doing. Test the edge cases, test all of the fault cases, and then robustness testing means that don't just test it for 5 minutes, 10 minutes, half an hour. Maybe have a couple overnight runs and dry run. Maybe have several 4-hour runs. But you have to be very diligent and plan forward how you're going to do your testing. We use standard tools whenever we're doing our testing, standard templates. These tools allow us to get to the bottom of what's necessary, pull the data from the system, and show in a clean and clear report that the test is proving that the system is doing what it's supposed to. And then save the evidence. Images are data. Save them all during your testing. Document what you've done. Have the customer with you during those testing processes, documenting that test, documenting its outcome, and documenting any kind of deviations from it. Their witness is only going to help you when you need to deal with anything that comes up. For deviations, allow quick adjustments to handle how you did work with your parts. Like for instance, our system is built on a PC-based platform using our Smart Vision software, which is non-compiled. If we run into a quick issue during testing and it's a matter of a 2-minute change within our interface, we can make that change, retest, and go and save a lot of time in having to go and complete that overall testing. Now, we've tested it. Hopefully the customer says it's okay, ship it. Now, how do we deliver it? Well, we deliver it by doing the same thing that we did when we tested it back at our site. We close the loop and we duplicate that same test plan that we did at our site at the customer site. But we also tie in all of the different types of changes associated with moving it to their site. Things like incorporating the next level of testing that they may have, IQ, OQ, PQ type testing if it's in a different type of environment, interfacing with their factory systems, their other equipment upstream and downstream. But when you do that, you have to do that in a manner in which you understand what those systems and differences are. At site, oftentimes with machine vision solutions, you'll find that the lighting is different, ambient lighting, than what it was on your floor. That may cause problems with your solution. Typically, we try and take out any kind of need for shrouding things by just using singular wavelength lighting with proper cut filters so that we're only looking at the light that we're producing inside the system, and ambient really doesn't come into play. Sometimes, though, you can't always control all of that. If you're working with color type systems and you're working with white light, it's a little more difficult to do that. So if shrouding is needed, know that the system's going to be going into an environment that's different than yours. Design that shrouding in and put it in up front. And then I think the last thing we have to look at once we've delivered the system and shown the customer that it's capable is to never stop serving that customer. It doesn't end just because they have the system now. Before you leave, make sure you've got a way to get at the system. Remote access into a system is critical from a servicing standpoint, and if you're willing to give them that service, they're really going to be able to benefit from that and take it and run with it. Provide clear and easy means for them to get a hold of you if necessary. Provide some training. Touch base periodically. You are the producers of your equipment. Be proud of your equipment and service it as on an ongoing basis. And then not only the equipment itself, but the technology. You're also the expert to them so that if technology changes that could affect them, don't be afraid to provide them with that information. Maybe that could lead to an upgrade that gives them even more performance. Today's technology allows a lot of ways of remaining connected, whether it's through Wi-Fi or cell services. But what you really want to do is you want to give them that bat phone treatment. If they pick up the phone, they know that you're going to be there. And bat phones are real. This one's down in my basement. I use it all the time. And with that, I'm going to say thanks everyone, and I hope you learned a little bit.
Thank you so much, Steve. We really appreciate the presentation you put there together, and I took away a couple of notes just for everybody to recap what was said. Steve hit on passable and acceptable are the parts, what you're looking to read, and is it something that's actually going to be acceptable to the end customer on top of it? You also mentioned think about the system as a whole, and I think that's really an important part that resonates with the rest of the presentations that we'll be doing today. And is it usable? You might get something that actually works, but is it actually usable in the end intent that's there? You also hit on contrast is king, and that's really important. Well, you want every part of the system to work to its maximum, so the more contrast you give in an image, the more powerful your software is going to become, and I thought that was really important. And also consider the fringe cases. That's something that can really get you. You get your system up and running, and all these fringy things start coming in, and then it's not working as intended. And I think that also gets to the other point that really resonated with me is you said test early and test often. And that's being a big thing, as you mentioned, was costly to fix later. So yeah, these are all great takeaways, Steve, and we thank you for your time on this today and really appreciate you being here.
Thanks for having me.